online. And now it's been sorted. So, yeah, chapter 10 is medians testing. Obviously, you've got your 3 techniques. For your one sample testing, where you compare your single sample against a unique value, a median, you can either do your sign test, which is 10A, I call it, like the first component. We'll do some of those straight away. Or you can do the improved technique, which is Wilcoxon sign rank. I've written here Wilcoxon sign rank is greater than sign. I've written it back to front. But yeah, sign rank is the better technique than sign. If you do have 2 samples, you are forced into the Wilcoxon rank, then sum technique. So this is sign and rank. Alright, so this is sign and rank, which is better than just sign, just the signs. If you force down the 2 sample route, where it's 2 separate samples, i.e. not paired, might be worth mentioning, paired data gets treated as a single sample. Paired data gets treated as a single sample. And because paired data gets treated as a single sample, you're going to do either the sign test or the sign rank technique. Okay? So depending on how big our sample is, depending on what type of sample we've got, is it a single sample, is it paired, can we do a sign or a sign rank? If we have a choice, sign rank is better. And if we have 2 separate samples, do the rank sum. You're being forced down the rank sum. Alright? And I'll talk about that more in detail later on. Focusing on the sign technique, then hopefully we get a chance to do some sign rank technique, which is the better technique, and then hopefully we get a chance to do a rank sum question as well. This question here from 2013 from the Legacy set is Jamal completed a crossword. Used to taking 32 minutes on average. Includes the name median. The Greek letter we use for median is eta. The issue that is facing us now, is it a 1 tail, is it a 2 tail? Use sign test 10% level to examine whether his median completion time decreased. So hopefully he thinks it's faster. Identifying the hypothesis is the same for sign and sign rank. They are both single sample medians tests. That's worth 1 mark out of 6. Okay? Because it's just the simple sign test, there's no sign then ranking, all I care about is did it take longer or less time than 32. Longer, so plus, shorter, 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 so minus, 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 minus. Longer, 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 so plus, plus, plus. Less, 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 so minus, 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 minus. Your signs is your second mark, your method mark of identifying the signs. I think that's 4 and 8. Can you confirm? Okay. So far so good. 1 mark for hypotheses, 1 mark for methodology on the signs. Now let's use the 4 and 8. Well, 4 or 8, we've got a choice. Yeah? The difficulty is the next mark. This is where students, at this point, they get this far and they stop. Yeah? The hard part to remember is that a simple sign test is a special case of a binomial. Alright? So every sign test you do is always a binomial p-value question. You're going to generate a probability of how unlikely a 4 or an 8 split is. So it's always 0.5, it's always 50-50. The reason why it's 50-50 is because half should be plus, half should be minus. We didn't end up with half and half, we didn't end up with 6 and 6. We ended up with 4 and 8. How unlikely is 4 and 8? Sample size of 12, thankfully, sample size is still 12. And using 12 and 0.5, we can either test 4 or 8. The choice is yours. If you choose the 4, 4 is your upper. If you choose 8, 8 is your lower. Okay? So if 4 is your upper, you always test away from what you'd expect. We'd expect 6 and 6. 4 is less than 6, so less than or equal to 4. 4 is your upper, 0 is your missing lower, using 12 and 0.5 as a BC. Dist binomial BCD, using 0, 4, 12, 0.5. How big we're talking? 0.2?
0.19.
190.
194.
Okay? The probability of a 4-8 split, or worse, the reason why I say or worse is because you're allowing the 3-9, you're allowing the 2-10, you're allowing the 1-11, you're allowing the 0-12. All those latter descriptions are less likely. You did it as a BCD. Now what do you compare it against? 1 till 10%. So we do compare against 10%. That is bigger than 10%. 10% written as a decimal, 10%, 10 over 100, 10 over 100, 0.1. Yeah, so converting a percentage significance level to a decimal is very common for p-value questions. What conclusion do you reach? We just generated what's known as a p-value instead of a test stat. Our golden rule of test stat, singular, I'll refer to why the singular is important later on. Test stat, singular, bigger, reject. That's not a test stat, that's a p-value. Your conclusion is opposite, it's flipped because it's a p-value instead of a test stat. So what I like to do is I remind myself, why did I say accept here? Why did I say accept? Because I said greater than, sure that's a reject. But unfortunately it's a p-value. So that's explaining to myself, not necessarily to an examiner, why did I accept there? Surely test that bigger reject, test that bigger reject, test that bigger reject. Test that bigger reject is the general rule of thumb. There's a few special cases. Anything to do with p-values, exact binomial, special case of exact binomial, sign test, and Wilcoxon's, which we'll be doing later on as well. I'll explain why Wilcoxon's different later. How's that as a reminder? Okay, so accept H naught instead of reject, and to complete the question of the reason why you accept the norm is because there's no significant evidence of the alternative at the median time for Jamal to complete his crossword. Has decreased. Sorry, mate. On average, your average for those 12 may be less than 32. However, there is no significant evidence that your average overall this year is less than 32 just yet. Maybe collect a bigger sample size. Maybe do a better test instead of a simple sign test. Notice he was able to do some crosswords in 11, 12, 14, 18. That's really fast. If we did a sign rank, we might have ended up with a different result. We won't do a sign rank just yet. I'll give you an opportunity to do a sign test, yes? And I think maybe a two-tailed sign test would probably be the shout. Should I make it purred as well? Should I make it purred so we get a purred in there as well? Let's find a purred two-tailed. Right, purred. Last Friday was glaucoma day, so that question's been enough. Siblings, is this one tail? No, it's one tail. That's one tail as well. Oh, never mind. I kind of want to do a two tail. Right, it's not purred. We'll do a purred Wilcoxon later on. Alright, that's what we'll do. We'll do a purred for Wilcoxon. I want you guys to have a go at a sign test here. This is two-tailed. Why is it two-tailed? Because it says test that the mean average, the median asking price was. The three of you online, I will ask for a p-value in the chat. When you have a p-value, type it in, but don't press enter. Do not press enter, because what I'll do is I'll ask you to press enter all at the same time.
What if it's the same number?
Good question. Unfortunately, you can't categorise it as a plus or a minus. So what happens there is you categorise it as a dot, as a zero difference, which means unfortunately just remove it from your sample. So make sure when you set up your binomial, your sample size changes. Six to three, is that right? 6 and 3? So it didn't specify increase, didn't specify decrease, it just says whether it was. So that's when it's a two-tail. I know it says 10 character, it says 10 prices, but that 10's been reduced because of that exactly 11,250. When you set up your binomial, there's only 9. Sign test is a special case of exact binomial using proportion 0.5. 50-50. Half should be plus, half should be minus, assuming that it's still that value. We're going to test for how unlikely the 3 or the 6 is. Just going to give 30 seconds for the online team answers to come through. Do not press enter just yet. I will I'm going to proceed with the question. You can vote on the conclusion, and of course you can give me test stats later on in other questions. Okay, so what p-value do we get here? You can choose the 3 or you can choose the 6. It's completely up to you. If you do the 3, 3 is your upper. If you do the 6, 6 is your lower. It would be 6 to 9 or 0 to 3. B, C, D. What do we get? 3, 2, 1, press enter now. Yeah, I agree. What about yourself, Brian? Good lad, thank you. 254? 254? That is a massive p-value, right? Clearly, that is bigger than 10%. Yeah? Let's just count up the marks that we've achieved so far in this question. First mark, hypotheses, check. Science, check. Model, check. P-value, check. We've got 4 out of 6. To get the 5th, we've got to make the right conclusion, which is clearly accept H0, because that p-value is too big. P-value bigger, opposite, test that bigger, reject. Test that bigger, reject. Test that bigger, reject. P-value bigger, accept. Yeah? But to get that 5th mark, I've got to say it's greater than what? What are we comparing now?
The 10%.
10% is a significant one. Yeah?
We divide it by 2.
But we divide it by 2 because it's a two-tailed test. So that 10% goes over the 2 tails, 5 and 5. So we're actually going to compare at 5%. We've done the left tail, we've done less than or equal to 3. That is bigger than 5%. If we did the right hand side, yes, we're going to do the same p-value, which is also bigger than 5%. 10% divided by 2 is 5%. Now we're going to get our fifth mark. So you only get the accept H0 if you compared with 5% instead of 10. Nice one. No significant evidence to suggest the price, the median asking price for a caravan was, be careful with this, not. The reason why he puts in not is because the actual way that it's phrased, test for it whether it was 11,250. That's your null hypothesis. That is H1. Now we're accepting H0. And the reason why we're accepting H0 is because there's no significant evidence of H1. H1 wasn't written in context. We're going to have to write it ourselves. So looking at H1, it's not. There is no evidence because we're accepting H0. No evidence of H1. H1, not. That same routine always applies. I hate it in those two tails where you've got to write the conclusion yourself in context instead of just copy and pasting it from the question. Alright? Right, that's sign test. Sign rank. It's the improved method. Let's do a paired data. Of course we can do it for a single sample. Let's do it for paired data. Before, after, local authority, highways. Okay, first thing to notice, and this we could have done a paired sign test. Okay. I just chose to do a paired sign rank, that way of taking off a paired as well as taking off sign rank. Notice here we don't have a single sample at all. We're comparing year versus year in paired data. There's your paired effect. And because it's paired, you're going to reduce the differences. And because you're reducing the differences appear in your hypotheses. We've done paired t-test. And in paired t-test, we write mu diff. Same is true for paired medians test. This time, e to diff. No value is mentioned, so we assume that they are the same, therefore there's a difference of nothing. One tail or two tail. Two tail doesn't specify what type of change, just says test for a change. So the difference between two isn't zero, i.e. there's a change. I'm going to make a note that we're going to perform a two-tail 9% because we're going to need that information, two-tail 5% and the sample size to read off the CV later on. Right, with it being two-tail, we can choose which order to do subtractions. If it was one-tail, we'd have to be specific. I'm just going to go down. Minus 3.3. 0, see you later, local authority B, you're of no use. Positive 0.8, positive 0.9. Do you want to complete that first? check those for me and tell me if you disagree. Minus 3.3, which comes from 5.6, subtract 8.9. Obviously 8.4 take away 0.4 is 0, so see you later, B. Positive 0.8 for C, positive 0.9 for D, question mark? Yeah, that's right, isn't it? 9.9 subtract 10.2, negative 0.3, negative 0.7 for F, negative 0.4 for G, minus 1.7 for H, 0.1 on the positive side for I, and minus 1.1. Quite a lot of negatives, only 3 positives, but we're not doing a sign test, we are doing a sign and rank method. Notice how straight away we're not just counting pluses and minuses, we're actually looking at how big they are. Hence why this is the sign and rank method. I'm actually curious about how far away from 0 they are. It may be worth jotting down a new table, because then we've got room for the ranks. And we're going to put the ranks in 2 columns. Depending what the difference was, whether it was positive or negative, we're going to put the rank in the retrospective column. Smallest difference, well, there was a 0, but B disappeared. We made B disappear. B had a difference of 0. So B, unfortunately, can't get categorized as a plus or a minus. Smallest difference is 0.1. Notice how it's positive, so rank number 1 goes in the plus column for I. Is there a 0.2? 0.2? No. 0.3, so rank number 2 for E, but notice how it's negative. 0.4, rank number 3, also in the negative, but this time for G. 0.5, 0.6, 0.7, so rank number 4 for the 0.7, in the negative for F. 0.8 and 0.9 next, so 5 and 6, but we're back over to the positive side. 1.1, rank number 7 for J in the minus column. 1.7, rank number 8 in the minus, and rank number 9. So the difficulty with sign rank is to stop yourself from just counting the signs. You need something to rank, so you need the actual differences. Whether it's differences against a single sample value, or whether it's differences within pairs. Okay? If it's against a value, your hypothesis will be median is value. If it's pairs, median difference is 0. Was the 10 local authorities reduced to 9? Because B is not going to be used. We've ranked them all. Any questions up until that point? Are we okay with that? So work out the differences. Smallest difference, regardless of whether it's plus or minus, gets rank number 1 and work your way up. You might get shared ranking, and of course you practice start throughout the course. What's next? Because you're going to get a test out from this, or test stats.
How many positives?
Well, instead of counting them, you actually assign rank, and because you rank them, you're going to add the ranks. So what we've got here is, yes, we've got 3 and 6, but what we really care about is how big they were. 5 and 6, they weren't that big. There was a lot of negatives. We had the biggest 3, we had 9. Rank number 9, rank number 8, rank number 7 in the minus column. So you never know. This might reject it. We don't. So the next thing to do is to total. of the ranks. 5 plus 6 plus 1 is 12. And is it 33 for the minuses? 9 plus 2 plus 4 plus 3 plus 8 plus 7. 33, yeah? 12 and 33. Cheers, Jeff. Thanks very much, bro. Alright. So there we've got two test stats. We're going to use the smallest, unfortunately. I'll remind you why in a second. Two-tail, 5% for a sample size. Well, there used to be 10 pairs. However, local authority B has no use, so that's turned it into sample size 9. We look up table 10. Table 10 looks like this. Two-tail 5%. Is that what we wrote down? Two-tail 5%.
Two-tail 5%.
So two-tail, so of the two rows of significance levels, we're looking at the second row. 5% means we're looking at the third column. If it was one-tail 5, we're looking at the second, but because it's two-tail 5, we're looking at the third. Yeah? So two-tail 5. And sample size, N, is 9, not 10. And if you combine two-tail, 5%, scroll down to sample size 9, you get a CV of 6. Okay, CV of 6. Many students, when answering this question, gave 8. And why is 8 wrong? Because they looked up 10. Can you see why the wrong CV, the most common wrong answer, was 8? Because they forgot local authority B reduced the sample size. Right, CV6, let's go. Table 10 gives us a CV6. Why are we using the lower one? Right, I need to explain that. Why are we using the lower one? Because it says in the question, the table gives lower tail critical values. And because it's got lower tail critical values, we have to unfortunately use the lower tail test stat. Okay? It says that in the question. That's why we use the lowest test stat. If you wanted to work out the upper tail, you could, but there's no need. Okay, so we use the smallest. 12 against 6, 12 is bigger than 6. What conclusion do we reach? I'm just going to do a vote, don't type it into the chat. There's two options, you've got accept H0 and reject H0. Can I have a vote on those, please? What conclusion would you reach if your test stat of 12 is greater than 6 for this test? What do you think? Yeah, because it's bigger.
And the opposite.
And the opposite, because it's Wilcoxon. It's that other situation. Couple of votes come through, one written and then one there. Okay, 2 written and 1 there, lovely. We do indeed accept H0 instead of reject. But for the purposes of the recording, but Phil, I always thought test stat, we're back to a test stat, bigger, reject. Yes, but I also refer you to my previous comment, test stat singular. Here we have 2 test stats and we're being forced to use the wrong one. Wilcoxon! It's not Wilcoxon's fault. Wilcoxon falls into that slim category where we've got to flip our conclusion. Test that bigger reject, test that bigger reject, test that bigger reject, unless you are dealing with p-values or Wilcoxon. We're in Wilcoxon, so. Accept the null hypothesis. And the reason why we're accepting H0 is because there's no significant evidence to the alternative. No significant evidence of that the median price, or median something, median percentage of expenditure. Expenditure towards highways. Spent on highways. There's no evidence that the percentage of expenditure has changed. Watched a cracking episode of not paranormal, what's it called? Is it paranormal? Oh, I forget what it's called. It's on BBC One, Monday evening, Panorama? Panorama? Does that sound like a TV show? I don't know. But they looked into why there's so many accidents and why is there an increase in road traffic accidents. Money. Less police officers to deal with the focus on other crimes. It's fascinating. Yeah, except takes no significant evidence of the alternative. The alternative was change. They didn't specify what change, hence why it was a two-time. Well done, well done. Right, for timing, I think rank sum. Is that alright? Alright. Or, I don't know, maybe we do another sign rank. I don't know, I'm not going to tell you. You've got to decide. Pay no attention to the file that's being opened on the board. Phil, I have no idea what a Mann-Whitney U test is. They rebranded it. Look at this data here. Alright. Students, if they're going to do this wrong, they do it wrong because they work out differences. They subtract out. Yeah? That's wrong. It's not per. It's not per data. There is no A, B, C, D to tell you that it's per. Okay? That is so important. So if I'm tackling this question from 2006 with an outdated name reference, you need to notice it is not per. And because it's not purred, you have two independent samples. You have two separate samples. And because it's not purred, because you have two separate samples, because it's an average, not mean, so median, the only two sample medians test is the Wilcoxon variation to rank their sum. I don't mind the name change. Right? The old exam board, the old spec used to refer to it as the Mann-Whitney U test. It was good because it reminded you that U was the test stat. Now that we've got Wilcoxons, that's good. There's a benefit for number one, because benefit number one is it's under the category of Wilcoxons, where your conclusions different. So that's quite nice. The other benefit is that it's called the rank sum method. Have a guess at what you're going to do. You're going to rank, and then you're going to sum. It's great. It's great. Any difference? Because you've got two separate samples, you have two separate medians. The median for the east side is equal to the median for the west side. So two separate samples, two separate eaters, two separate population medians. It's a two-tailed test that just says any difference so two-tailed 5% might be worth making a note of. Sample size 9, sample size 9. The smallest weight, rank number 1 for the west side. Then we're into the teens, or at least low tens. Rank number 2 for the 11.7, 14.1 for rank number 3. Rank number 4, 14.7, I'm liking this. All the small ranks in one side. Then we're up top. For rank 5 and 15.3. 6 and 7. 6 and 7 at the same time. 6 and 7 at the same time. 6.5, 6.5, carry on with 8 then. Right. Oh, flimming jib. What have I done? What have I spotted? What's the issue? 15.7, 15.7, what fun is? What hasn't got a rank?
15.4.
Yeah, so that was rank 6, which means 7 and 8 at the same time. 7 and 8 at the same time, 7.5, 7.5, carry on with a 9. Carry on with a 9. Oh, halfway there. 10. It's all over the place, isn't it? 16, 17. Whew! God, blimey, a good rank sun takes it out of you, doesn't it? 14, 18, 7.5, 17, 9, 5, 16, 7.5, 15. Whereas the west side has quite a lot of small ranks. 2, 4, 10, 12, 1, 3, 11, 6, 13 and 6. East side will have a higher rank sun than the west side.
So do you add east side separately? And
Correct. Correct. Rank. Now that we've done the rank, have a guess what we do next. Rank then. So, total for the east side, total for the west side. Listen to Phil trying to sound gangster. West side is the best. No. East side is the best. Two, 48, 65, 17, 101, 109. 18 times by 19 divided by 2 is 171. 171 means 62. Can you confirm those? Where's that? Yeah? Now, obviously, east side has a bigger rank sum total than west side. Unfortunately, they both came from a sample size 9. This question was harder to identify because the sample sizes were the same. Some students would have identified this as paired, i.e. work out differences, when in fact it's not paired, it should be done rank sum. Now rank sum can be done for 2 different sample sizes because it's 2 completely different samples, not per data. So we need to accommodate that sample size, alright? So when you're looking up your critical value, hopefully you get a reminder for rank sum that U is the test statistic. Oh, I've not got a U, I've got a T and a T. U is T minus N plus 1 over 2. Here, thankfully, N is 9 and N is 9. So we're going to use 9 at the same time twice. There are questions that need practice where you end up with two different sample sizes and you'd use 10 times 11 divided by 2. Here we've got 9 times 10 for both test stats. So yeah, the actual test stat itself, which is in the formula book, we're looking at table 11 for the CV, but there's also a formula for the test stat. So Mann-Whitney U had a nice little reminder to work out the U test stat, but the formula does remind you as well. So table 11 says rank sum, and it does say in writing U equals T and T minus N plus 1, 1 and 2. So test stat for each side, start off with 109, subtract 9, 1 more than 9 is 10. Test side for the west side, also 9. If it was a different sample size, we would use a different value there. Nine times 10 divided by 2 is 45. 45 more 6 is 17. 45, 64. Can you confirm 64 and 17? 64 plus 17 is 81. 81 is 9 times 9. I'm happy with 64 and 17. I feel like it satisfies everything that I would get for a rank sum question. The total is 81. 81 is also 9 times 9. Saddle math fact. 64 and 17, yeah? Of the two, which one do we use? The smallest, the 17. Let's get ourselves a critical value. Remind me, was it a two-tail 5%? Yeah, two-tail 5%, because those are our hypotheses. Eta does not equal eta. We said it was a two-tail, because it says test whether there's any difference between the two sides. Difference in weights between the two sides. Yes, two-tail 5%, 9 and 9. We're going to use two sample sizes. It's just there's two tables, isn't there? The top table is the one-tail 5%. That's not the table we're looking at. We're looking at the two-tail 5%. So before you read off 9 and 9, make sure you read off the right table. So 9 and 9, I think is 18. Okay? Yeah, so two-tail, 5%, read off 9, read off 9. Wow, this question is super close. Test stat of 17 and CV of 18. What's the conclusion? For the benefit of the chat, can I have a vote on the two answers, please, instead of typing it? We've got one answer so far, just looking on one more vote. Okay, you agree with each other? Correct. Correct. Test stat, the wrong test stat is less than. For this situation, is a reject instead of accept because Wilcoxon! In this incident here, there is significant evidence to suggest a difference in median weights of growth or whatever between the two sides of the hill. Yeah? 6 marks for a sign test. 9 marks for a sign rank. 9, maybe 10 for a rank sum. I know it says 12 there, but I don't think it'll be 12 now. Up to date marks. That's a lot of marks. Yeah? I think the key is just to keep practicing it. Just keep practicing it, keep practicing it. I said it last week and I'll say it again. If you have printed off that PDF, you've got the ability to tick off in lesson, in lesson, in lesson, in lesson, in lesson. So far, everyone's covered that from what I'm hearing. What did we revise last week? We did a bit of correlation and testing, is that right?
Yeah.
And then this week we're ahead and we've done a bit of that, and a bit of that, and a bit of that. Yeah? Obviously, we'll cover it in class. It might not be in the next 2 weeks, but we will eventually cover it in class. Yeah? What I recommend is this third column. Okay, I've practiced that, I need to do some practice of that myself. I've done some of that, I need to practice some of that myself. So in class, it needs to be paired up with stuff outside. In a tutorial, it needs to be paired up with stuff outside. So this that we've done together today, do some more, gain some confidence in it, pick up some more marks. Okay? Thank you very much for your attendance. Muchly appreciated. I will see you next week. Or Friday. Right, so who did I